Are you tired of that annoying screen tear ruining your immersive gaming experience? Ever wondered why your high-end gaming rig still can't deliver perfectly smooth gameplay? Let's explore the technologies designed to solve these frustrating problems. VSync versus GSync, choosing the best solution to eliminate screen tearing. Screen tearing occurs when your GPU renders frames faster than your monitor can display them. This mismatch causes parts of multiple frames to appear simultaneously, creating a visible horizontal split in your image. At a technical level, VSync works by implementing a frame buffer. When enabled, your GPU renders a frame and stores it in this buffer until the monitor completes its refresh cycle, ensuring perfect timing between frame delivery and display. The double buffering technique used by basic VSync can cause significant input lag. This happens because while one frame is being displayed, another is waiting in the buffer, and your inputs affect a frame that won't be displayed until the next refresh cycle. Triple buffering attempts to address this by adding another buffer, allowing the GPU to render ahead while reducing wait times. But this comes at the cost of increased memory usage and still doesn't eliminate input lag entirely. GSync uses a variable refresh rate (VRR) module built into the monitor. This module contains a specialized FPGA, field programmable gate array, that communicates directly with compatible NVIDIA GPUs via DisplayPort to dynamically adjust refresh timing. The GSync module takes control of the monitor's timing controller, allowing refresh rates to vary anywhere from 30 Hz to the monitor's maximum rated refresh rate, providing smooth gameplay across a wide range of frame rates. GSync-compatible monitors, unlike full GSync displays, don't include NVIDIA's proprietary module, but instead use the VESA Adaptive Sync standard. They offer similar benefits, but may have a narrower effective range and less consistent performance. VSync's frame rate cap can be particularly problematic in CPU-bound scenarios. When your CPU can't feed frames to the GPU fast enough to match your monitor's refresh rate, VSync forces the display to wait for complete frames, causing noticeable stuttering. GSync eliminates this problem by allowing the monitor to refresh immediately when a new frame is ready, regardless of timing. This adaptive approach maintains smooth motion even when frame rates fluctuate dramatically during gameplay. Modern VSync implementations often include frame rate compensation techniques like adaptive VSync, which automatically disables VSync when frame rates drop below the refresh rate, reducing stuttering at the cost of occasional tearing. The input lag introduced by VSync can be quantified. At 60 Hz, each frame takes approximately 16.7 nms to display. VSync can add an entire frame's worth of delay, effectively doubling your input latency in worst-case scenarios. GSync's specialized hardware allows for frame delivery with minimal processing overhead, keeping input lag close to the theoretical minimum for your current frame rate, typically just 1-2 seconds above an unsynchronized display. For multi-GPU setups, GSync offers superior frame pacing compared to VSync. When running SLI or NVLink configurations, GSync helps manage the sometimes irregular frame delivery from multiple GPUs, providing a smoother experience. Power consumption differs between these technologies too. VSync can actually reduce GPU power usage by limiting frame rates, while GSync monitors typically consume slightly more power due to the additional processing hardware. GSync also includes additional features beyond tear elimination, such as ultra-low motion blur, ULMB, which strobes the backlight to reduce motion blur, though this feature typically can't be used simultaneously with GSync's variable refresh rate. The DisplayPort requirement for GSync is another technical consideration. While newer HDMI standards support variable refresh rates, full GSync functionality requires DisplayPort connectivity due to bandwidth and signaling requirements. For developers, GSync requires no special code implementation, working transparently with existing rendering pipelines. VSync, however, often needs to be managed carefully in engine code to balance performance and visual smoothness. When benchmarking systems, it's important to note that VSync can artificially cap performance metrics, while GSync allows for more accurate performance measurement by maintaining GPU utilization while eliminating visual artifacts. Thank you for watching our comparison of VSync and GSync technologies. We hope this technical breakdown helps you make the right choice for your gaming setup. Remember, the best solution depends on your specific hardware, budget, and gaming priorities.